Okay, so we're going to work through the study guide here. Hopefully you have this out in front of you. You can see exactly what we're doing. Question number 1 asks about the gas law triangle. Now, we already talked through this. We did this on the board the other day. Just reminder how to work the triangle. The way it works is in each corner of the triangle represents the different scientists. So G is Gay-Lussac, C is Charles, and B is Boyles. Those are our 3 scientists that we talked about. Okay? And the way they work is Boyles, remember the 2 variables that impacted him was pressure and volume. And notice that's what comes together to make Boyles. Charles, the variables were volume and temperature. They come together to make C. Gay-Lussac's, his variables were pressure and temperature. And then to make the equations out of them, so for example, Boyles is P times V. So Boyle's law is P1V1 equals P2V2. Gay-Lussac's is P over T. So Gay-Lussac's is P1 over T1 equals P2 over T2. And then Charles' law is V over T. So Charles is V1 T1 equals V2 T2. Now remember the combined gas laws. Combined gas laws is all of them. If you look at everything we have pressure and have volume. Both of those are over temperature. So combined gas law is pressure and volume both over temperature. P1V1 over T1 equals P2V2 over T2. And so those are the gas law triangles that you'll need to know for Charles, Boyles, Gay, and then also I put in there the combined gas law. Now just a reminder, the back side of your periodic table for the test tomorrow has all of those equations. Right underneath the polyatomic ion list are all of those equations. So if you don't have those committed to memory, you're okay, but you need to be able to look at that and make sense of it in order to get those questions correct. All right, let's look at number 2. Number 2 says solve for the final volume. So right now I know, all right, the final volume is what I'm solving for. And then reading the question, the gas inside of a flexible container at 25 degrees Celsius has a pressure of 0.25 atmosphere. Now remember, with gases, we don't like Celsius. We're changing those to Kelvin. The way we do that is we add 273 to 25. 273 plus 25 is 298. Same as we go down here, the size of the container starts out holding 3 liters. When it's heated to 30 degrees Celsius, we don't like Celsius. We want to add 273 to 30 and we get 303. So these are our temperatures. The first one, that's T1. So 298 Kelvin is T1. T2 is 303 Kelvin. We always want to express them in kelvins as our unit when we're talking about temperatures. Okay, so let's go back. We have pressure right away. So pressure is measured in atmospheres. So I know, hey, that's my P, and that's where I started. So the first initial pressure is 0.25 atmospheres. The final pressure is 0.27 atmospheres. And the initial volume given here is 3 liters. Okay, so now I have everything asked for here except for V2. So to solve for V2, I got to figure out what equation do I need. Well, I have pressure, I have volume, and I have temperature. So it's not Gay or Charles or Boyles. It's all of them put together. It should be my combined gas law. So I'm going to use this as my equation. I'm going to use P1V1 over T1 equals P2V2 over T2. Now, I could go and take and plug these all in. You could do that. That's totally okay to do. But remember, what we're solving for is V2. So the easiest way is to get V2 by itself. So to get V2 by itself, I need to get rid of P2 and get rid of T2 from this side of the equation. In order to do that, I have a fraction. So if I have P2 on top here, I need to have P2 on bottom here. So I divide by P2. Then I can cross that out and cross it. Those will cancel. However, if I have P2 at the bottom on this side, I need to put P2 over here as well. Now that's great. I got rid of P2, but I have T2. To get rid of that, I got to put that up top. That would go up here, and now T2 cancels. But if I put it up on top on this side, I also have to put it on top on this side. Now I've canceled out everything on this side of the equation except for V2. Okay, and now I've had to add some things over here. So to rewrite that equation, if I do that again, it's V2 all by itself equals T2 times P1 times V1 all over T1 times P2. Now it's a lot easier to go back and plug in all those numbers. When I do that, okay, I get T1, right? T1 is, sorry, we'll start with T2. T2 is 303 Ks, that's Kelvin, times P1, which is 0.25 ATM, times V1, which is 3 liters. All of that goes over T1, which is 298 K. By the way, now I can cancel out K and cancel out K, times P2, which is 0.27 ATM. And now I can cancel out ATM and ATM. 303 times 25 times 3. And then I take 298 times 0.27, and I divide those two numbers. If I do that, V2 equals 2.8, and the only unit I haven't crossed out is my liters. So it's 2.8 liters, which is consistent with the unit used for volume. Okay, so that's how I solve that. I need my combined gas law. Here's what I plugged in, solving for V, get V by itself, plug in the numbers. There you go. If your sheet doesn't look like that, push pause, fix it, and then let's go on to number 3. All right. Number 3 says, how much pressure in ATM does 4 moles of nitrogen gas at 30 degrees Celsius exert on a container that holds 55 milliliters of gas? Again, I don't like Celsius. I want to get to Kelvin, so I've already made that change. Remember, I just add 273 to 30. 30 plus 273 equals 303 K. So that's going to be my temperature. Right now I can go 303 Kelvin. Now what else do I have in here? Well, I have moles. I'm asking for pressure. How much pressure? So right now I can say, all right, that's what I'm trying to solve for. I also have liters, and liters is a unit that's consistent with volume. So that's going to be a volume, 55 liters. Okay, now I have 2 new variables. I have N and I have R. If you remember, the only equation with N and R was good old Pivner. PV equals nRT. So pressure, volume, temperature, N, remember, stands for number of moles. Right here in the equation it says number of moles, that's 4 moles. So I'm going to write that in. And R is my constant. R, remember, on the back side of the periodic table will be listed as 0.0815. Okay, that's a constant. You don't have to calculate it. You don't have to know that. I will give that to you. So I just gave that to you. 0.0815. Okay, and then I just go Pivner. Right, I go right here and I plug it in. Now I could take all of these and plug it in, but what am I solving for? I'm solving for P. So it's easiest to start with by putting P all by itself. So I want to get rid of V. So how do I do that? Well, if I divide out V here, I can cancel that out, but then realize if I divide it here, I have to divide it here. And so now what I have is I have P equals nRT all over V. And now I can go and much more easier plug that in. Okay, so I have 4 moles times R, which is 0.0815, times T in Kelvin, right? Temperature in Kelvin, 303. And that goes over volume. Volume is 55 liters. Okay? So 4 times 0.085 times 303 times 55. If I do that, I get 1.8 ATM. And I know it's ATM because that's a measure of pressure. And it says how much pressure in ATM. 1.8 ATM. Okay? That's number 3. Let's move on to number 4. What must the final temperature be of a gas that was 112 kPa at 20 degrees Celsius if the final pressure is 89 kPa? The gas is in a metal containing that holds 2 liters of gas. So I have a couple things. I have kPa, pressure. I have temperature. Let's get rid of Kelvin, bring it to get rid of Celsius, bring it to Kelvin. Okay, that's temperature. I have pressure again, kPa. And then I have liters, which is volume. Now, if you wanted to use my combined gas law, because I have pressure, volume, and temperature, you can do that. However, they also tell you the gas is in a metal container that holds 2 liters. It doesn't change, so it's a constant. So if you remember, of our scientists who held volume as a constant, that was Gay-Lussac. He just did pressure and temperature. So you could either plug it in here and just do volume is 2 liters here, volume is 2 liters here, or you can use Gay-Lussac's and take volume all together because volume doesn't change. It's a constant. So I could just take that out. So I'm just going to use the Gay-Lussac's because it's shorter. All right, so I'm going to go P1 over T1 equals P2 over T2. And then plug it in. What do I have? Well, this asks, what's the final temp? So what I'm solving for is T2. This is what I need to get, T2. All right, the gas was 112 kPa. So that's my initial, 112 kPa. That's my initial pressure. Okay, the initial temperature, we want to put that to Kelvin, 293 K. And that equals a new pressure, final pressure, which is P2, which is going to be 89 kPa. And I'm solving here again for T2. Now I plugged it in. How do I do this? The easiest way is probably just to cross multiply. Okay, so if I take my calculator out, where's my on button? Can you see that? Maybe, sort of, kind of. All right, we'll put it right there. If I take my calculator out, I take 293 times 89. I'm going to cross multiply these two. I get 26,077. 26,077. Okay. Equals, and then I'm going to cross multiply this. Well, that's easy. That's 112 kPa. All right. And then T2. Now I want to get rid, and I don't even need to write that in. I want to get rid of this because I want T2 all by itself. So if I divide 112, that cancels. But if I divide this side by 112, I need to divide this side by 112. And now I have that, which is equal to the only thing left, which is T2. Now in my calculator, I can take 26,077 divided by 112. And my answer is, if I got it right, T2 should be 232.8. And that's temperature, so again, we measure that in Kelvin. And that's my final answer for number 4. Okay, you're doing great. Let's do our last one on this page, and we'll take a little break. Number 5, how many moles of carbon? So I'm looking for moles. Crud, right now, I know in my head, looking back at my equations, the only thing that deals with no moles, no moles, no moles, no moles, the only equation that has moles is good old Pivnert. PV equals nRT. So I know, all right, I'm solving for N. How many moles of carbon dioxide gas do you have? The gases that are in a pressure. So my pressure is going to be 1.3 atmosphere. Temperature, 28 degrees Celsius. We'll fix that to 301 Kelvin. In a container that holds a volume of 3 liters. So I have volume, pressure, temperature. The only thing I'm missing is R. Okay, now remember, R is a constant. That's on the back side of your periodic table. R, and we will always give it to you, is 0.0815. So that's R. So now, if I have N, I got to get N by itself. So how do I get rid of R and T? Well, can't I just divide by R and T? Cross it out, cross it out, cross it out, cross it out. But if I divide this side, I also have to divide this side. If I rewrite that, that's N equals PV over RT. And then I can just plug in my numbers, right? Pressure is 1.3. Volume is 3.0. R is 0.0815. And temperature is 301. So now I can go 1.3 times 0.0815, and on the top I get 0.10595. On the bottom, 0.0815 times 301, I get 24.5315, and then I can just divide those. 0.10595 divided by 24.5315 equals, there's my answer. Okay, and if I did it right, I get, oh, sorry, lost my track. If I did it right, I got 4.32 times 10. I don't know if you can read my calculator. It says 10 to the negative 3. And again, this is N, so this is moles. And that's how you answer the first page. All right.